So good morning from my side. I want to talk about, when you talk about intuitive industries, you got to talk about digital. And you've heard it this morning. It was powering and digitization in the industrial world. 80–90% of the discussions we have is in respect to digital. How can we digitally improve the end-to-end productivity of our customers, or of the end customers, the users of industrial automation in production. So Jean-Pascal said it this morning. I don't want to go into these details, but I think important is to talk about the 30 billion connected things that we're seeing to come until 2020. That's a huge amount of sensors. It's a huge amount of actuators. It's a huge amount of data that will be generated in industrial factories. And as you've been penetrated already with our EcoStruxure architecture, but what I want to say is when you talk about this connectivity, when you talk about the Internet of Things, it really starts off with the things. It starts off with the products that are deeply embedded in the manufacturing sites that generate data. Now you could say, okay, you know, we know this for 30 years or for 40 years or 50 years when the first PLC controllers came to life and they aggregated data, and that has not changed since. What did change, as a matter of fact, is that sometimes these products or sensors that create data in the site, they may not use the edge controller anymore, but they may report the data somewhere else. And you see this with the arrows on the side. So the traditional automation pyramid that many of us have known and have studied in their life, this is disappearing. It's becoming flat. I don't want to say the world is flat because we know it's round, but at least the architecture in that respect has become flattish. And when discussing productivity, it's not about necessarily anymore can we compare one edge control to the other, but it is how can the system improve the productivity. And when talking to many customers, talking to many of you, there are a lot of companies out there that says, you know, okay, I can do all of this with artificial intelligence. So, you know, I've gone out and meet with many of them and say, you know, why don't you scale this much larger? They say, well, what we're lacking is domain know-how. Okay, it makes a lot of sense to me. And you would also say, you know, when we're automating something, it's important to understand the process. It's important to understand the equipment. It's important how to understand how to increase productivity. You know, and that's when we talk about the areas or the domains of expertise where we, together with the machine builders or the line builders or the end users, combine our knowledge and then digitize it to go forward. And I'd like to talk about that this morning in respect to 3 areas where we see this driving the digitization in our industrial world forward. Now, these 3 areas that are moving fast ahead is, number one, is the end-to-end integration of from a product idea to the finished product. You have the integration of the industrial engineering software. And I'll go a little bit more into detail with that and how that influences many of our sites and many of our customers. Secondly, there is a large ecosystem of developers out there at our partners that create and drive thousands and 10,000s of applications that run on our layer 3 in the EcoStruxure, in hybrid industries, in discrete industries, and also in continuous industries. And also I'm going to talk about an example and the importance of the openness of this architecture or this platform to invite others to participate in it with their specific know-how that they have. And then thirdly, we can see a rapid expansion of opportunities to the new IoT services. 2 years back, you would have heard me talk about there are 4 types of customers that we see out there. Number one are the ones that say, this trend is gonna go away. I don't need to worry about it. Secondly are the ones that say, I gotta embrace that and see what it means. And so they started understanding. The third ones are those that say, I go in concrete applications. I try it out, I move forward, and I see how I can create value with the technology, not just using the technology for fun, but create value. And then the fourth one are those that have gone into mass implementation of some of the POCs, proof of concepts that they have done. So 2 years later, I don't meet the first category anymore. So there are no folks out there saying this is going to go away. And you can see that this is happening with a much more rapid speed than we were used to in the industrial automation sphere. Many of us have been in the industry for a very long time. It's like the Hotel California. Once you're in, you can check out any time, but you're not allowed to leave. And so we're in the industry for a long time. Now this is accelerating. It's the first time that I've seen in the 28 or 30 years that I'm in the industry that a trend like this is accelerating so much. Now let's talk about the end-to-end industrial software. You've seen this chart earlier. And while these were 2 worlds in the past, the world of people that would do the design of a process and then also a design and how to build the plant. You would, in larger facilities, that's where the EPC comes in. They get the design, the process design from their customer, then they do the build. And once they're finished, site acceptance test is finished, and roughly 2 to 6 years are over when a large plant is built, then it's operated for 30 to 50 years. The operation cycle usually had nothing to do with the build and the design. Now that's totally changing because we see many of our end customers when they do the process design, so the chemical design of a plant, what kind of pressures to use, what kind of temperatures to use, what kind of piping to use, what valves and so forth. They want to prescribe to the EPC what kind of engineering system to use, because while in the past you would still have a lot of interfaces between the design software and the build software, so the 3D plant design, these interfaces will go away. Actually, we're working on it actively that they will go away. And while you then have a digital representation of your plant, why not feeding real live data in the operation into the digital representation, so you can very far offside of your plant. You can look digitally at your plant with the real-time operating data that you have, where you can train people, where you can then also go away from real-time data to simulated data, train your folks, and with augmented reality bring those things together. While at the same time, you can use all the data that you have to do quite a bit of prediction on what's going to happen. Now, many customers tell me, yeah, that's all nice, sounds very good, but I'm not planning on a greenfield the next 10 years, but I have a lot of plans installed. So how do we move forward if I only have a brownfield? And I said, the key thing is the data, the transparency, and how you decide what to do with that data. And you've seen across earlier that Jean-Pascal was showing. At the center of that is, how do I aggregate data, make it visible, control the process, be able to make decisions, and do this in a very, very nice format. So at the center of it is monitoring, visualization, asset operation, and control. Now, that's at the center of every application in our view, because it will allow you a very nice view on the assets that you have deployed, and obviously on those assets you want to increase the return that you had invested in your capital expenditure. but you also want to increase the profitability of your day-to-day operation. Now, how would this look like in a pretty high-end application? Let's look how the largest monitoring and control center with world-class visualization. It's very important that it's world-class visualization. Many of you have probably been in operation centers where you see a lot of data only specialists understand, but it is important to have world-class visualization and control capabilities. Now, this control center that I'm trying to visualize now, can you start it for me, please? It's not working. Oh, it's there. It's not here. It's only there. So this small control center is 3 times as wide as the total screen that you see here. It's 150 feet or 50 meters, where ADNOC has, so that's the Abu Dhabi National Oil Company, they have connected all facilities that they have, and it's not a few, all, into one control room where they can easily show and visualize data, and then also make decisions based on the data that's there and control their operations. Now, when you talk to the CEO of ADNOC, His Excellency Dr. Sultan Al-Jaber, he would say, we've built this to grow our company in the next 15 years to one of the largest national oil companies, and we're able to make decisions faster than ever before, eliminating a lot of guessing because data is communicated forward and backward, and a lot of mistakes are made in that respect. Now, when you have all this data, so what are you going to do with it other than looking at it and also making some decisions and so forth? Obviously, a lot of people talk about artificial intelligence, for example, and I'll comment on that in a minute, how we can use that. But remember, if you've an end-to-end process and you've designed your plant with a very nice 3D CAD tool for plant commissioning, you can go in this visualization, and you're not looking at a lot of data, but you can actually look at the 3D design of some of your plants. You can zoom into a specific asset and see what kind of data is available. And then when you have that data, why not trying to predict what's going to happen? And you see this here on the right-hand side, very small on the top. But I've brought, of course, an example with you. And here we're using sophisticated mathematical methods that analyze historic data that is there to predict what's going to happen if you continue to run the asset as it has run before. And the example I'm bringing here is from India. It's one of the largest power generators currently in production and in build process. It's roughly, they have 18 gigawatt of power plants that they're building. And they have given us data from 1 year of operations to feed it into our analytics engine and to tell them what would happen next. And we could tell them that by looking at the data, what would happen to the individual turbines that are running there. So these turbines are 800 megawatt of size. These are pretty large machines, among the largest machines that are out there. 800 megawatt is huge. And so what our software, our diagnostic software, found out that they could see and trend the temperature of a bearing, and the bearing is not of this size. It's pretty huge, and they get very hot, and they're externally cooled. That the temperature was trending in a direction where they could say the turbine is going to degrade very shortly. That's the second worst case that can happen to a power generator. After degrading comes failure. And so we could predict that this would happen. And if they say if we predict something, it's a catch. And every catch has a value. So we predicted that this bearing would fail if something would not happen. They were looking at the time where the energy consumption went down. Then they drove down the turbine, checked the cooling of the bearing. There was a fault. They fixed the fault, brought the turbine back on the network when the power was required, and had a nice saving of 270,000 just for this one catch. Now, that's just one example, but I can tell you this predictive asset analytics software is the fastest selling software package that we have in our portfolio. It's widely deployed around the globe, in particular when there are large assets that are rotating, for example, so turbines or also compressors and so forth. Now, after you've kind of built your digital model of your asset and you improve the return on capital employed, that's the horizontal axis here. Obviously, your plant is in operation, and you want to continuously also improve the profitability in that respect. In respect to planning, how is the asset optimized or used, the scheduling of your folks, and then also optimizing the asset operation. And again, not all for greenfield, but important is that this can be deployed in brownfield operations, because that's what we're faced with. A very nice example of that is one of the largest refineries in the world. It's in India, Yamnagar. We've started off with phase 1, and that goes back to 1998. And I think just finished very recently phase 3 of this huge refinery out there. And you can imagine that 20 years ago, some of the software packages that exist today weren't there at the time. So, but we've done the full automation system here in that respect, DCS system plus safety shutdown system and so forth. And within our DCS system, we have a very good link to the software that we're offering. And with that, we could do install an integrated refinery automation information system that would allow them to do some simulation, some asset performance management, and with that increase output of the refinery, which is of course at the end of the day what counts, by reducing downtime, by also reducing the running cost in that respect. And when I talk about end-to-end productivity, that's what it's about here in that respect. Now, we've been talking a lot about continuous processes now, like a power or oil and gas or petrochemicals. But the same is, of course, true when you go into hybrid or discrete industries. When you move to hybrid and discrete industries, of course, it's extremely important to have a network of partners out there that can work together very closely with the customer to do just that, what we explained earlier here in some of the continuous industries. So in that respect, I'll show you a couple of examples what we've done in that respect and what the customer said. This is a very nice sugar manufacturer in South Africa. And by accident, we have my brother Peter here, who's the system integrator, CS Solutions from South Africa, who made this happen. It's quite a large installation with, and yell in if I say something wrong, a couple thousand IOs, a redundant hybrid automation system. I think it's in the neighborhood of 6,000 to 8,000 IOs that we've installed. And this plant was there for many, many years, and quite an old automation system installed. And some of the folks at the customer said, well, we're trying to make decisions based on experience that we had, and not based on hard facts of data that's available at different levels of the customer. Data that's available targeted to the operator, or data that's available targeted to the supervisor, or data that's available to the plant manager, because at different levels you need different data to make the right decisions, not based on your gut feeling, but based on solid historical data that is there, and maybe also some advice in what decision do I make, what does that mean to the profitability of my operation. So Peter and his team have helped RCL to do all this installation. It was a pretty big one, and you know, the numbers speak for themselves. 39% increase in sugar production, and that pays off fairly quickly. And so, at least from what I know, the folks are very happy down there. But you can ask Peter; he's gonna let you know. Now, when we move a little bit more into discrete applications, I want to talk about the utilization of the industrial Internet of Things to create advanced applications out there with new value offerings. And interestingly enough, or not surprisingly enough, when you move into a discrete machine manufacturer, you have a pretty similar process than I've shown earlier. You try to design the machine, engineer it, commission it, then you go into operation, you hand over at that point in time to your end customer, where you also want to utilize maintenance and services. Now, why can't we use all the data that and all the information that was generated throughout this process of design, engineering, and commissioning, also later on in the phase of the operation of the machine in a digital manner? Now, you've seen earlier the example that Jean-Pascal has shown with Somic, who is a machine builder in Germany, doing some of the most productive coffee capsule packaging machines, and they are extremely complicated, up to 70 plus servo axes with virtually no cabinet in there anymore. So all the drives are decentralized in the machine. It's been a very complicated machine. Now, as an end user, you would imagine, well, I'm a little bit scared in using a complicated machine. Then you want to give service capabilities to them where they can easily connect with you, and you'll see that in the video. But not only for machinery, the same can be done in the plant, and in the digital world. I shouldn't present everything, but have the digital twin take care of me here for a second and enjoy the video for a couple of minutes.
Produkte in einen Umkarton verpackt. Mein Name ist Patrick Bonetzmüller und ich bin der Geschäftsführer der Somic-Gruppe. Schneider Electric EcoStructure mit seinen Produkten wie Augmented Operator Advisor, PackDrive LMC Pro und die Servo-Drives ermöglichte für uns, unsere Maschinen, die maximale Performance zu erzielen.
Tenaris es proveedor líder de tubos de acero y servicios para la industria mundial energética y otras aplicaciones industriales. Actualmente, la planta cuenta con la más alta tecnología y es considerada una de las plantas más eficientes e integradas de su tipo en el mundo. Produce una amplia gama de productos para el mercado energético, automotriz, para aplicaciones agroindustriales y exporta sus productos de alto valor agregado a todo el mundo.
Abordamos el piloto de realidad aumentada en el ánimo de buscar una solución que pueda involucrar datos de gestión, mantenimiento y planificación en general. La idea era tener en el piso de planta una interfase que nos permita ver esos datos en tiempo real, y por eso recurrimos a la realidad aumentada. El lugar elegido había sido la línea 3, nuestra última línea de montaje, de ajuste de tubos de acero sin costura, y precisamente nos orientamos a una máquina de ultrasonido que hace control no destructivo por ultrasonido.
En Schneider Electric desarrollamos un sistema de realidad aumentada, el cual permite, a través de una tablet, tener información a pie de máquina. Realidad aumentada es el término utilizado para poder indicar en una visión del medio real superposición del medio virtual. Esa información proviene de distintas bases de datos, SQL, PLCs o SCADA.
El piloto se desarrolló trabajando con la gente de Schneider de manera conjunta. Nosotros elaboramos los requisitos, ellos hacían las propuestas y todo se fue desenvolviendo bastante bien. Llegamos al día del piloto, donde se hicieron las pruebas, y destacamos que en tan solo 15 minutos pudimos tener el sistema funcionando. Eso fue algo muy importante para nosotros. Finalmente calificamos como exitoso el piloto, donde pudimos cumplir los objetivos y planificamos en un futuro poder desarrollar esta misma tecnología en otras mismas partes de la planta.
So you see, we also speak other languages than English. But what's important is you've seen a machine builder and an end user and something that was newly developed, and also a well-established plant out there where we can utilize the technology to increase the output. Now, all of you know that the second discussion that you have after you discuss the technology on IoT and how it can create value is end-to-end cybersecurity. It's a big concern of many of our customers and end customers, and how to deal with that as let's say the OT and the IT world are potentially moving closer together, and how we can handle that, in particular when we're talking about very long ago installed brownfields that are maybe now combined with a couple of new technologies that have been showing out there. And so the question is, how can we assure a defense in depth at the customer, not only on the new products, but on the complete installation that is there, no matter what vendor has installed the automation technology 10, 20, 30 years ago. So when thinking about that, we said we got to install a team that can go out and consult our customers, that can actually also go out on the shop floor and evaluate what's going on the shop floor, make suggestions how the network should be looking like, make suggestions on what needs to be done to make this place a secure place. Sometimes some of those control systems still run with, I don't know, Windows 3.11, or for those who are a little bit younger than I, that was out there 30 years ago. But it still is running, and if you send an IT cybersecurity guy there, he's going to say, okay, we're going to run an update on this one, and so done at one of our customers, and a couple of seconds later the whole plant was shut down for a pretty long time, because they needed to call in specialists who understood how to make this 3.11 machine safe, while at the same time ensure that production is going on. So you need folks that understand production, and that understand cyber, and that understand how the networks function. And that's the cyber offering that we give and offer to our customers around the globe. It's a special breed of folks, and I invite you to one of the sessions this afternoon where one of the experts talks about that. Is I think extremely important to worry about in critical infrastructures and critical plants that we're talking about. And I'll give you a short example before my time runs out. that is a specialty food ingredients manufacturer that has 17 plants around the globe. They've chosen one to start off with, and some of the installations are as old as 20 years. Obviously, we start off looking at some of the products. It's as simple as checking how many USB interfaces do you have on the shop floor, who has access to them, where can they go, what kind of operating systems do you run, do you have, are you still using the passwords of the original equipment manufacturer of 1985, which you can Google in the internet. And these kind of things, all these kind of things need to be done on any kind of equipment, and that's what the folks have done here in one plant, secured one plant, and then roll out into several. As one example, and you'll surely hear more about those this afternoon. So that kind of concludes my presentation. End-to-end software plus ecosystem of partners out there for all industries, and making use of the latest technology and trying to make it cyber secure. These are the things that we're seeing to happen in the industry. Here are a couple of interesting sessions today that you may want to work on. If you want to go to the end-to-end software, you need to visit the Aviva presentation, which is our sister company, where we've merged our software into. With that, I'll let you go, and hope you have an interesting day in respect to industry and digitization. Thank you very much for your attendance.